Welcome to the Etops lesson. In this lesson, we will discuss Etops definitions and regulations, as well as provide scenarios for various operations. From the first commercial flight of the 1920s, air travel has evolved to become an efficient mode of transportation. This efficiency led to an increase in popularity, and by the late 1940s, people wanted to fly further distances, opening up the need for long-range operations. By the 1950s, the safety of long-distance air travel and the reliability of the piston engines had reached its limits. In 1953, regulations came out requiring commercial airlines operating twin-engine aircraft to stay within 60 minutes flying time of a suitable airport at all times. This drastically restricted where and how an airline could conduct its flight operations. By the mid-1980s, authorities recognized the reliability of jet-powered turbofan engines and provided an extended-range twin-engine operations, or Etops, exception to the 60-minute rule. In 1985, the first Etops flight was flown successfully from Boston, Massachusetts to Paris, France. Today, Etops stands for Extended Operations. The Etops area for twin-turbine engine-powered aircraft is when the aircraft is beyond 60 minutes from an adequate airport, using one engine in operative cruise speed under standard conditions in still air, also known as drift down. The Etops regulations have been modified to include aircraft with more than two engines. However, for the purpose of this lesson, we will be focusing primarily on the twin-engine aircraft regulations. Flights that operate beyond 60 minutes from an alternate airport require Etops authorization. To explain the concept, let's consider the following example. Assume your airline wants to fly from A to C, New York JFK to Madrid, Spain. There is one adequate alternate airfield, B, within range, and that is Terceira Island, Lagos. The 60-minute rule is indicated by the red lines, which show the maximum range the aircraft can be from an alternate airport at any time. As a result, the flight is not permissible under the 60-minute rule. However, if a 120-minute Etops authorization is received, as indicated by the green lines, the flight may proceed to its destination following the route AXC. Based on the 120-minute area of operation, flight from New York to Madrid is possible with only a small deviation from the direct route as originally planned. Another aspect of Etops regulations addresses engine reliability and other critical Etops systems reliability. Etops critical systems include power plant, electric, pneumatics, air conditioning, and hydraulics. Etops authorization requires sufficient redundancy and reliability to ensure the airplane can get from A to B safely. Additionally, operators need to demonstrate flight planning expertise and a much more rigorous maintenance program. Over the years, Etops has proven to be a safe and reliable practice that not only provides airlines efficient and flexible flight operations, but also provides the air-traveling public improved safety and reliability. Etops operations allow airlines to go more places and try new routes and markets that may be cost-prohibitive with larger aircraft. It also enhances existing routes by improving overall maintenance reliability and schedule performance. While there is a cost investment to Etops operations, the payoffs will affect the entire operation, not just the Etops routes. The U.S. Code of Federal Regulations 14 CFR Part 121 regulates Etops operations. This section will primarily focus on the highlights of the regulation as it impacts flight crew procedures. Refer to 14 CFR for more details regarding the regulations. Etops authorization of extended operations for twin-engine aircraft applies when the aircraft is more than 60 minutes from an adequate airport. For 3- and 4-engine passenger airplanes, it applies when the aircraft is more than 180 minutes from an adequate airport. The regulations require that Etops diversion times cannot exceed the time limit minus 15 minutes for the aircraft's most time-limited system, which is usually cargo fire suppression. The regulations require satellite communication or satcom voice communications for all extended operations beyond 180 minutes. Another form of communication must also be available in areas where satcom technology is unusable. Other communication systems like VHF, HF, and satcom or HF data link have limitations that can compromise the reliability of communications during extended operations. To qualify as an Etops alternate, the airport must be classified as an Etops adequate airport. An Etops adequate airport must satisfy the following 3 conditions. First, it is appropriate for your aircraft type. Second, it meets the stated requirements for use during a planned diversion. And third, the airport is listed in your op specs. Once determined as adequate, in order for an airport to be classified as an Etops alternate, it must also meet the weather conditions, which are at or above operating minimums for the time required, have firefighting and rescue equipment available for use, and be available for diversion use. More information on Etops alternate airports will be presented later in the lesson. The regulations specify Etops dispatch or flight release requirements for weather conditions at Etops alternate airports. Weather information must also be updated at the start of the Etops phase of flight to verify the continuing availability of alternate airports. The regulations for twin-engine jet aircraft specify a critical fuel reserve. Critical fuel reserve is the amount of reserve fuel to be carried to protect the aircraft in the event of a cabin depressurization followed by an extended diversion at low altitude to an alternate airport. Fuel reserve planning must assume this event happens at the most critical point on the flight route. Fuel reserve requirements will be explained in depth later in the lesson. A recent change requires 3- and 4-engine passenger airplanes to carry an Etops fuel reserve on Etops routes. The FAA has also implemented a non-Etops provision, requiring all 3- and 4-engine aircraft to carry a decompression fuel reserve whenever they fly beyond 90 minutes of an airport. Although U.S. regulations specify supplemental oxygen in the event that cabin pressure is lost, some operators and flight plan suppliers have not specified sufficient reserve fuel for the aircraft to reach an alternate airport during a low-altitude diversion. The regulations require all flights on extended routes with diversion times beyond 180 minutes to prepare a passenger recovery plan. This plan ensures the well-being of passengers stranded at diversion airports and provides for their safe retrieval without undue delay. Crews need to be aware of the plan. The regulations require all Etops operators to provide their flight crews applicable performance data to support their extended operations. Finally, the regulations require that rescue and firefighting equipment be available at any airport designated as an Etops alternate. It is important to understand the difference between Etops and extended overwater operations. While extended overwater authorization allows the aircraft to fly more than 50 nautical miles from a shoreline, Etops authorization is necessary to operate further than 60 minutes flying time from an adequate alternate airport. Etops flights require additional maintenance inspections, additional equipment, and are subject to more limiting MEL restrictions and special operating rules not required for extended overwater flights. Etops authority was established to allow twin-engine aircraft to fly between the U.S. and Europe. There are a number of Etops authorities available based on your operational needs. For example, there are Etops authorities for 75, 90, 120, 180, 240, and beyond 240 minutes. At this point, there is an Etops authority available to accommodate almost any city pairing in the world. Typically, the 120-minute Etops authority is obtained to allow twin-engine aircraft to fly between the U.S. and Europe. However, the 120-minute Etops authority would not allow twin-engine aircraft to fly between the U.S. mainland and Hawaii. As a result, 180-minute Etops authority is required for twin-engine aircraft to reach Hawaii from the mainland. Etops circles are a graphical tool provided by an operator's flight planning software that displays the areas where a twin-engine aircraft can fly under Etops authority. The circles are defined by assuming an airspeed of 300 knots indicated airspeed or Mach 0.80 in still air. The circles always represent a distance, and each circle is centered on an adequate airport. For a route to be legal under 120-minute Etops authority, it must lie entirely within circles representing 120 minutes flying time from an adequate airport. For a route to be legal under 180-minute Etops authority, it must lie entirely within circles representing 180 minutes flying time from an adequate airport. To explain these concepts further, let's take a flight from Seattle, Washington to Maui, Hawaii. This will utilize the 180-minute Etops authorization. The flight plan will indicate an Etops entry point, an equal time point, and an Etops exit point. The Etops entry point, or EEP, is the point on the outbound leg of the intended route at which Etops airspace begins. This is the point where you are at 60 minutes flight time at 300 knots indicated airspeed, or Mach 0.80, from an adequate airport. The equal time point, or ETP, is that point at which the diversion times to the two closest Etops adequate airports are equal. This can also be referred to as the Etops critical point. The Etops exit point, or EXP, is the point on the inbound leg where Etops airspace ends and will be at 60 minutes flying time at 300 knots indicated airspeed, or Mach 0.80, from an adequate airport. It marks the end of a particular Etops segment. Adequate airports are used to define where Etops airspace begins and ends. One factor that governs the decision on alternate airports is the definition of adequate alternates. An adequate alternate must meet certification and performance requirements, have an ATC facility, provide weather reporting, have at least one nav aid, have access to rescue and firefighting equipment, and conform to Etops weather requirements. The Etops weather requirements are: a ceiling and visibility addition is applied to the lowest minimums at the airport, not lower than Cat 1, based on the number and type of instrument approaches available at the field. Separate nav aids require independent runway surfaces that do not intersect or touch at any point along their length. In addition, there is a time requirement for these weather conditions at an alternate. Specifically, the weather must be forecast to conform to Etops weather minimums from 1 hour prior to the earliest possible time the aircraft could arrive, to 1 hour after the latest time the aircraft would arrive, following a diversion from the equal time point. If a diversion is necessary, published minimums apply at the diversion airfield, not Etops weather minimums. Etops weather minimums exist only for determining the best choice for an adequate alternate in accordance with Etops flight planning requirements. Flights within Etops airspace must conform to the most restrictive of either international fuel requirements or, more typically, Etops fuel requirements. In many cases, flights to and from Europe will be dispatched under international fuel requirements. However, if the flight you are operating is to or from Hawaii, then Etops fuel requirements will always be the most restrictive. The Etops fuel requirements are as follows. The aircraft must carry enough fuel to divert from an equal time point to either related alternate airport. It must be able to hold at 1,500 feet over the alternate airport for a period of 15 minutes, initiate an approach, initiate another approach, and complete a landing at the alternate airport. This must be able to be accomplished assuming the worst of the following three possibilities has occurred at the equal time point: an engine failure, followed by a diversion to the alternate while maintaining 300 knots indicated airspeed until the hold, a depressurization of the cabin, or an engine failure and a depressurization of the cabin, again using 300 knots as the diversion airspeed. A depressurization of the cabin is typically the most detrimental of the three possibilities with regard to fuel burn. The following situations would require additional fuel to be added to Etops flights: any MEL or CDL burn penalties that apply to the aircraft, the in-service deterioration correction factor value, which is added to burn fuel automatically as a result of the cruise burn percentage listed in the computer flight plan section and entered in the CDU, APU fuel burn for engine inoperative conditions during a possible divert from the equal time point, a 5% wind forecast error, a percentage of ice accretion burn to compensate for ice buildup on the non-heated portions of the flight controls, wings, and fuselage, which is based on forecast icing condition and listed on the flight plan as full, 2/3, 1/3, or off. Or your operator may impose an ETP fuel pad that can be anywhere between 300 to 1,000 pounds, added to compensate for any unforeseen contingencies. Continuing with the Seattle to Maui flight, this topic will take you through a typical preparation for an Etops flight, from pre-flight planning to procedures prior to entering Etops airspace. Not all steps will be included here, just those unique to Etops requirements. Refer to your operator's manual for specific information on all phases of flight. Most likely, the planning phase will start with a dispatch briefing. A dispatch briefing is required any time a flight will be operated internationally with a planned flight time greater than 5 hours. While a flight to Hawaii will begin and end on U.S. soil, you will need to keep in mind that an international flight is defined as one that has a point of origin or destination outside the 48 contiguous United States. It is no longer required to do an HF cell call check on the ground, but it is highly recommended. Ensure that if the check is performed on the ground, it is done when refueling is not in progress. If the check is performed in flight, it must be completed prior to entering oceanic entry point. The VHF frequency to be used for an HF cell call check can be found on the -7 page of the departure airport or by calling AirInc on a VHF frequency to receive an HF frequency. An international flight folder contains the paperwork, such as the flight release, flight plan, a weather package, and a navigation chart. The captain is responsible for verifying the accuracy of the flight plan. The flight plan is used to record position report information, re-release data, meteorological information, and other pertinent flight data. Any discrepancies must be resolved with dispatch prior to departure. When verifying the flight plan, the captain must ensure the computer flight plan routing and requested altitudes agree with the ICAO flight plan routing on the release, and ensure the computer flight plan coordinates agree with the actual coordinates from your high-low altitude en route charts, the track message, or other approved navigation charts. Additionally, review the Etops summary section on the flight plan. Compare the Etops fuel summary with the ETP fuel on the master flight plan. Make sure fuel estimates over the ETPs are greater than the fuel required to divert at each ETP. Also review the list of adequate airports. If there is a concern with one of the alternates listed, contact dispatch for further guidance. In addition, the ice accretion or ice drag factor will be noted on the flight plan. This value will be listed as full, 2/3, 1/3, or off based on the forecasted icing conditions for the route of flight. For Etops flights, the first officer normally performs a fuel reasonableness check. Most often, the operational standard permits no more than a 2% error tolerance. While the captain is verifying the flight paperwork, the first officer will be preparing the Etops orientation chart. Plot or chart the primary flight plan track, and if desired, the secondary flight plan tracks, along with the equal time point or points. When this is done, the captain must check the waypoint coordinates from the Etops orientation chart, while the first officer verifies them against the master flight plan. The use of the Etops orientation chart is mandatory. However, if an orientation chart is not available, a high-low en route chart may be used instead. As with any other flight, the pre-flight tasks include logbook inspection. Ensure that a line check has been accomplished and that any write-ups have been addressed. For Etops operations, there are additional requirements concerning the logbook review, which include the Etops pre-departure check, or PDC, and oil watch boxes. An Etops pre-departure check is required for all Etops operations. The pre-departure check includes a review of the critical Etops systems, and it must be completed within 4 hours preceding pushback from the gate. If pushback cannot be accomplished within the 4-hour limit, an extension may be granted, provided the delay was not due to an Etops significant system maintenance issue. You will need to refer to the MEL to determine if a system is considered Etops significant. The MEL shown here identifies that an MEL exists for the air conditioning packs. The MEL states that 2 packs are installed, but only 1 is required. However, under the Flight Crew Operating Procedure column, it states Etops operations are not authorized. If one of the packs fail while sitting at the gate, and it takes over 4 hours from the time the original pre-departure check was completed to fix it, another PDC would need to be completed and the logbook signed off accordingly. Back to the logbook, the oil watch boxes must be signed off by 2 different mechanics. If an Etops verification flight is necessary, details will be included in the remarks section of the logbook. Once airborne, there are specific Etops required steps that need to be completed. Much of the planned route will be conducted in Class 2 airspace. Before leaving Class 1 airspace, a navigation accuracy check must be accomplished. A requirement of oceanic airspace not driven by Etops rules is to be at the filed altitude at your oceanic entry point. Therefore, ATC must be notified if unable to reach cruise altitude by the route entry point. 3 items must be checked and verified with your dispatcher prior to entering Etops airspace: weather at the alternate airports, fuel status of the aircraft, and maintenance status of the aircraft. No later than 30 minutes prior to reaching the Etops entry point, dispatch will send a message verifying the weather at the alternates and will ask the captain to verify that it is legal for the flight to continue into Etops airspace. If the maintenance and fuel status of the aircraft are satisfactory, the captain is expected to reply with a "Captain concurs EOK" message. The flight cannot legally continue into Etops airspace until the message is received by dispatch. When Etops entry point is reached, a position report should be sent to dispatch identifying the name of the position. Be aware that position reports made directly to the ATC facilities may not be automatically forwarded to your operator. Position reports made to AirInc facilities are forwarded to both ATC and the operating airline. Certain communications failures relating to HF communications are commonplace over parts of the Pacific. An HF data link failure does not necessarily mean you will need to divert. Note that HF data link is not required for Etops operations. However, HF voice is required. For the remainder of the flight, there are no unique Etops procedures to follow, and the flight will proceed as any normal flight operation. In this topic, we will cover 2 scenarios: less fuel at equal time point, and a loss of an engine at the equal time point. Consider this fuel scenario. Your estimated fuel over the equal time point is less than that listed within the 180-minute Etops summary on the flight plan. Note, this is the value required for dispatch. First, do not divert. The fuel required to divert from the equal time point to associated alternate as listed on the flight plan is not regulatory while in flight. Instead, contact dispatch for a fuel requirement recalculation based on current weather conditions and a possible altitude change. Dispatch will be able to provide a more detailed analysis of fuel requirements based on the specific situation. In the event of an engine failure at the equal time point, consult your operating manual. It may be listed as RVSM in-flight contingencies. Most likely, the aircraft will not be able to maintain altitude in this event. Review your operator's manual for guidance with pilot flying and pilot monitoring duties when unable to maintain altitude. During an engine-out divert while unable to maintain altitude, there are some unique Etops decision-making scenarios regarding speed that are worth addressing. The FMC engine-out cruise speed is equivalent to L/D max and is typically an indicated airspeed in the low 200 knots. This function favors maintaining a high altitude over a faster speed. It also provides the greatest fuel economy. The 300 knots indicated airspeed is normally used by dispatch for fuel planning purposes. This speed will offer the shortest diversion time at the expense of the greatest fuel used. Consult your aircraft's performance charts for specific airspeed requirements. Use the performance charts to set the EPR on the remaining engine based on the given altitude and weight to attain 300 knots indicated airspeed. Also, use the performance charts to approximate fuel flow and equivalent true airspeed. Long-range cruise, or LRC, speed provides a good compromise between time savings and fuel savings if time is a factor during an unplanned divert. Consult your aircraft's performance charts for specific conditions. It also offers guidance for the EPR setting on the remaining engine, given the altitude and weight of the aircraft. Also use these charts for an approximation of indicated airspeed or Mach value, fuel flow, and true airspeed. We will now cover an example of an eastbound transatlantic flight. It will focus on normal pre-flight and en route procedures specific to Etops operation. Your pre-flight duties will start with reviewing the International Flight Folder, which includes the flight release, the flight plan, a weather package that will include NOTAMs and an upper air and surface weather depiction, an orientation chart, and a track message. Review the flight release for accuracy and check for fuel reasonableness. Since the flight plan contains a re-release section, review the flight plan re-release fuel data comparison. Verify the computer flight plan routing and requested altitudes agree with the ICAO flight plan routing on the release. Check destination alternates for reasonableness. Pay close attention to those items that can affect Etops status, RVSM status, or communication capability. If any item disqualifies the aircraft from Etops or RVSM operations, or if it requires alternate routing to stay within VHF radio coverage, contact dispatch to ensure the flight plan reflects the fuel requirements for the new routing. If an MEL item restricts your flight to 120-minute Etops operations, contact dispatch to ensure your routing is legal. The remarks section will have the final flight plan information. The captain is responsible to verify the accuracy of the flight plan. Any discrepancies must be resolved prior to departure. On eastbound flights to Europe, the most likely route is on a defined track. If this is the case, during pre-flight, review the track message. Ensure the correct procedures for the eastbound Atlantic crossing are followed. Next, verify that the computer flight plan coordinates agree with the actual coordinates on the orientation chart. As part of the Etops fuel verification, make sure fuel estimates over the ETPs are greater than the fuel required to divert at each equal time point, as indicated in the Etops 180-minute fuel summary. Mark compulsory reporting points on the flight plan with a solid triangle. Position reports are normally required in 10-degree longitude intervals. Waypoints across the Atlantic are usually 10 degrees apart. Review reported and forecast weather conditions at departure, destination, destination alternate, and Etops alternates to ensure weather conditions are adequate. Keep in mind that weather and field conditions for Etops alternates must be at or above weather minimums 1 hour prior to the earliest arrival time until 1 hour after the latest arrival time. These times can be found in the Etops summary section on the flight plan. Check NOTAMs and verify suitable conditions exist at the field. Review the appropriate ATC pages for information on each country that will be flown over. Typically, the first officer will prepare the orientation chart by plotting the primary flight plan track, Etops entry points, equal time points, and exit points on the route. Unlike the Hawaii example, transatlantic routes typically include more than one equal time point. The captain will verify the waypoint coordinates with the orientation chart, and the first officer will check them against the master flight plan. The orientation chart is mandatory, but if one is not available, it is acceptable to use the high-low altitude chart. Because this flight will be longer than 5 hours, the captain will need to conduct a dispatch briefing with the flight dispatcher. Once on the aircraft, review the logbooks, ensure the line checks are complete and valid, check that the Etops pre-departure checkbox is checked and signed, verify the oil watch boxes are signed off by 2 different mechanics, and ensure the Etops verification flight procedures are complete and signed off. At this point, the first officer should verify the accuracy of the fuel load. Normal procedures required for any international flight should be followed. Prior to entering Etops airspace, check and verify with dispatch weather at the alternate airports, fuel status of the aircraft, and maintenance status of the aircraft. Remember, in order for the flight to remain legal under Etops authority, the captain must report back to dispatch, "Captain concurs EOK," 30 minutes prior to reaching the Etops entry point. Once in Etops airspace, complete position reports and ensure to remain in HF voice communication. The westbound procedures are similar to that of the eastbound example shown earlier, with a few differences regarding random routes worth mentioning. Similar to eastbound flights, for westbound routes, the first officer will prepare the orientation chart based on the flight plan. If a westbound random route is planned, it will not conform to the published tracks issued by Shanwick Oceanic. Random routes require more northerly routes of flight and are normally flown to avoid strong headwinds and turbulence. A unique characteristic of this route is that the aircraft will never be more than 60 minutes away from an adequate alternate airport. The flight is planned so it can be completed without actually entering Etops airspace. In this case, the dispatcher has a few options. The flight can be released either as an Etops flight or a non-Etops flight. Let's assume that dispatch prepared the flight plan using 180-minute Etops authorization. There will not be an Etops entry or exit point on the plan. However, there will be equal time points listed between the alternates. The advantage of this is that Etops airspace is available to use if necessary due to weather rerouting or an in-flight contingency. The captain will want to discuss the flight planning rationale with the dispatcher during the pilot dispatch briefing. The captain will check the orientation chart plots against the waypoints, while the first officer verifies them against the master flight plan. Notice that this northerly route will bring the aircraft near the Greenland depressurization area. This is an area of high-altitude terrain, and it is a critical awareness item. In areas of high terrain, the aircraft would not be able to descend quickly to an adequate altitude in the event of a cabin depressurization. Refer to your operator's manual for more information on the Greenland depressurization procedures. Once on the aircraft, review the logbook as usual. Because this flight is scheduled as an Etops flight, ensure the Etops pre-departure check was completed. Even if the flight is not flown as an Etops flight, maintenance will always assume that all departures to the United States are Etops flights and will perform an Etops PDC. When departing from an international location, most likely the fuel slip will be completed for you. However, it is still a good idea to review it to ensure accuracy within a 2% error tolerance. Blue spruce routes are used when the aircraft does not have HF capability. Therefore, it will be routed to ensure VHF capability at or above flight level 300 over the entire span of the transatlantic flight. A similar route will be necessary if an MEL item prevents the aircraft from using Etops authority. Satcom is an alternative to an HF phone patch. Unfortunately, there are areas in the North Atlantic where Satcom signals are poor, particularly westbound areas between Greenland and Iceland. Over the years, pilots and dispatchers have observed areas between Greenland and Iceland where incoming Satcom calls are of poor quality, but outgoing calls from the aircraft are usually of better quality. Therefore, it is recommended that if an incoming call is of poor quality, consider hanging up and initiating a call back to dispatch from the flight deck. Following a landing at an unplanned destination, you will need to know if an Etops pre-departure check is needed prior to takeoff and re-entering Etops airspace. Any diversion due to a mechanical issue requires that a PDC be completed prior to re-entering Etops airspace. Note, if the next flight segment will not enter Etops airspace, a pre-departure check is not needed. If the unplanned diversion was not due to a mechanical issue, consult your operator's manual for further guidance on flight continuation after diversion due to a non-mechanical procedure. This concludes the Etops lesson.
That is incorrect. That is incorrect. That is incorrect. That is correct. That is correct. That is incorrect. That is correct. That is incorrect.